Alright everyone, Mr. Claxton coming back at you here with solving absolute value inequalities. The last video just wasn't quite right. I didn't quite have the mic set up the way I wanted it to. Hopefully you're not hearing that deep breath into the microphone now. Solving absolute value inequalities, there's a lot of stuff going on here. I want to make sure that you know what we're trying to do. When we solve absolute value inequalities, we treat the absolute value itself like a parenthesis. It's a grouping symbol, after all. So we want to isolate it first. We want to get it by itself. The way that I explain this to students is when solving equations, I use SADMAP. SADMAP is just PEMDAS backwards. When simplifying, I would use PEMDAS. I would go this way when I simplify. And I always want to simplify before I solve. I always want to make it easier on myself before I solve, if possible. When I solve, I go SADMAP, meaning I want to add or subtract anything first. Then I want to divide or multiply. After that, I want to take care of all exponents. Then last, I'll take care of the parentheses. I give an example of that down here. When solving 3x minus 2 equals 4, you would first add 2 to each side, and then divide by 4. Understand how this is much different than what we would do if we were simplifying. And we would only simplify here if we had a value for x. Say if x were 8. If x were 8, I would substitute in 8 first. Okay, and I would follow PEMDAS. I would multiply or divide, and then I would add or subtract. By the way, if x were 8, 8 times 3 is 24. 24 minus 2 would give us 22. So, looking at that, I want to rewrite, after we isolate it, rewrite the absolute value expression as a compound inequality. You gotta flip the inequality if you change the sign. When a negative comes along, you must flip it. Flip it good. Into shape. Alright, so that's kind of like, that's the best I can do right now. At night, on a Wednesday night. That's the best saying that you're going to get out of me. We use OR if the inequality points to the constant. In most cases, this will, I know that you can read, so I'm not even going to read that to you. I'm not going to insult your intelligence. I give a hint down here. Pause it. Probably the easiest thing to remember is that you use AND when the absolute value points, or when the inequality points to the absolute value. A and the A. So right down here, I did give an example of wanting to isolate the absolute value first. I want to isolate that first. I'll go ahead and erase this over here. I did these two examples in class. We have the same and then the flip version. Notice how the absolute value is already isolated, so I don't need to add or subtract anything to isolate it. I then rewrite the inequality as a compound inequality. And I really should have written OR up here whenever they are connected by OR. The reason being is because the inequality, points toward the constant. It points away from the absolute value. Once we get down to the solution, that's after we set it greater than 11 or less than negative 11. Notice how I flipped it good. I get x is greater than 3 or x is less than 8. Now I've shown you two different ways you can write this. For you people who like to shade and darken in and really make it apparent that you are including all solutions greater than the value 3, you can put it right on the line. If you don't do that, then I want you to draw it above the line. Less than negative 8, obviously over here, less than negative 8, and obviously that includes all the solutions to this absolute value inequality would be values less than negative 8. That's negative 8.01, negative 8.018, negative 8 million would be a solution to this, as well as 3.2, 3.23, 3 million, or 100. Notice how the only solutions, the only time that you can plug a value in and not get a true inequality are these values in here. That will not give you a true statement. And that's why the picture is so important. It's showing us what will give us a true statement. If you look down here, I have a common sense example. I call it a common sense example because absolute value always means positive. And if I add 1 to each side here, if I add 1 to each side, you know you're going to get the absolute value of 5x is greater than negative 10. I have it written right here. And if you look at that, anytime you see an absolute value compared to a negative, you should know something's different, or something is obvious here, right? Because an absolute value is always going to be greater than a negative. Absolute value is always going to be positive. Logically, because a positive is always going to be greater than a negative, you can write all real numbers. All real numbers would be a solution. I can plug in any number I want to here, and I am going to get a true statement. That's what that means. So all real numbers are solutions. I showed that by coloring in the entire number line. As a side note, by the way, I should have an x on this number line because it does represent all x values. And I should have an x on this number line that represents the x values. Well, look down here. Should have an x on there as well. So I do need to do one operation in order to isolate the absolute value here. I isolate the absolute value by multiplying by 3 on each side. After I multiply by 3 on each side, that's when I break it down into a compound inequality. I have case A and case B. I always like to talk about them. Two different cases here. I have the case where it looks the same, only I take out the absolute values. 2x minus 5 less than or equal to 3. And, because it points to the absolute value, case B, 2x minus 5 greater than or equal to negative 3. So, because that's a negative there, I had to flip it into shape all around. All right. Understand, I do not want to change this color scheme to improve performance. Come on now. I just want to keep it. Sorry about that interruption. What would life be without random interruptions? So, understand, I do have the word and connecting these down here. Probably shouldn't be writing that with my mouse. I could write it a lot better with the InterWrite device. So, after I graph that, what am I going to see here? So, I'm going to go ahead and go back to here, and I'm going to graph x is less than or equal to 4, and x is greater than or equal to 1. And I'm not going to forget that. So, let me go ahead and grab the x is less than or equal to 4. Well, let's see. I can go ahead and make this right here 0. 1, 2, 3, 4. We'll go to 5 just for good measure. Remember, I guess that would be the key word there. X is less than or equal to 4, which means I'm going to color in that 4. And I know that it's going to point this way. Now, I'm not going to take it out very far because I know, if I look back, that x is greater than or equal to 1. So x is greater than or equal to 1. And again, because there's an and statement, it's the intersection that's important there. So the intersection where these two intersect, I'm going to go ahead and shade that in, this nice green color here. Notice how I include 1 there. They intersect at this point. Some teachers like to show that by drawing it up here. This goes forever to the left, from and including 4 to the left, and then this red solution down here, greater than or equal to 1, goes forever that way. Because it's an and statement, I am only taking what is the point where these two intersect, where they both share those common solutions. So understand the solution set here is only between, well actually, and including 1 and 4, right? It includes 1 and 4, and it's all values between that, which is an infinite number of solutions still. We won't get into that until later on in the year, but I do have an infinite number of solutions in between here, and I have an infinite number of solutions here, and I have an infinite number of solutions here. So in all cases, I have an infinite number of solutions. understand the solution set here. Without getting into number theory, I'm just going to go on from there. I'm not going to go out on a tangent. So hopefully you understand just a little better now how absolute value inequalities are solved and what that solution looks like graphically. And remember the steps as well. I had one more common sense example. Right here. So we have another common sense example. The negative of the absolute value of x plus 2 is greater than or equal to 5. So I'm going to go ahead and finish this up. Just in short, that's like saying negative 1. This right here, that negative on the outside, is like saying negative 1, and I'm multiplying negative 1 times the absolute value of x plus 2, and that is greater than or equal to 5. I have to isolate the absolute value first. In order to do that, I can multiply or divide, but I'm going to divide by negative 1 and divide by negative 1. And when a negative comes along, you must flip it good, into shape, all around. Okay, I'm getting carried away. Come back. See what happens when you get carried away? You lose your train of thought. You got to stay focused. Okay, and you know that we're going to have a negative 5 on the right-hand side. So let's think about this. Another comment. Anytime I have that absolute value compared to a negative and an inequality in between, is this always likely to happen or never likely to happen is what I want to ask myself. Can an absolute value ever be less than or equal to a negative? I hope you were thinking no. No matter what value I plug into here, I can plug in negative 1 million. I'm still going to add 2 to that negative 1 million. So that would be negative 999,998. Take the absolute value of that, and I'm going to get 999,998. That's going to be a positive value, and that's not going to be less than or equal to negative 5. So understand, it doesn't matter what I plug into here. I'm going to get a false statement. That's whenever we get to write the ever-famous phrase, no solution. And we like this because when it tells us to graph our solution on a number line, without drawing a rectangle, when it tells us to graph it on a number line, we don't have to do anything. We just write no solution, right? And remember, that is the X number line. No solution means it's not going to be any of those. I can put tick marks all I want to. But you know what? I don't have to color anything in. So again, I do hope that you understand absolute value inequalities a lot better now. Look for those common sense examples first and understand whenever you have an absolute value isolated compared to a negative, you're with an inequality in between, you're either going to get a no solution or an all reals. So you got to decide on which one. I call them common sense examples. Hopefully this helps you out. If not, well then I have no way to give you the 10 minutes of your life back that this has taken. So good luck, and do your homework.